Hello, my dear students. Welcome to most expected MCQ series. So, before going to the next, I would like to give you my short intro. So, myself is Dharamveer Kumar Mishra. I am having 18 plus years of teaching experience in GATE, ESC, PSU, and other competitive examinations. So, here in these videos, I am going to discuss you that most expected questions, that questions along with their concepts also. So, why I started this series here, because as per my past experience for so many exams I had checked that questions and similar to that, or even sometimes it has matched the exactly same questions. So based on that experience, I'm going to set that questions, going to discuss that question which will be useful for IOCL, which is having that very recent notification came. Then apart from that, regular RRB NTPC exam, which is CBT computer based test. Then after this, APGENCO, APTRANSCO, A and J, PSU, state PSC, and apart from that, like many times, these questions will be very useful for engineering services examination, and even other than that, whatever is the state level exam, based on these things, like so many questions will be directly matching to there. So here in this series, I'm not going to discuss only the questions, I'm going to discuss questions along with their related concept, their surrounding concepts also, so that from the subject, whatever questions they'll ask in that competitive exam, you'll be able to answer many more questions, and by that way, your life is going to be changed. So this series, I can say that this series will change your life, because you're going to fight for the job, and there my best wishes along with this preparation strategy will be always there, along with the most valuable content also. So now, without delaying into this series, now I'm moving to this subject. So the subject, first of all, I have taken as electronic devices. So here what you have to do, what the questions I have selected here in this series, so that questions will be reflected first, and meanwhile you need to mark that as like question number 1, 2, 3, 4, and so on, and arrow, just put the arrow in front of that number and give your answer, then match with my answer, and accordingly you can get your scorecard also by yourself by evaluating those questions whatever answer is given by me. So here I'm going to start first of all with this electronic devices. So now the first question what I had taken, that topic is semiconductor physics under this subject. So the question here is the energy gap of an intrinsic semiconductor at room temperature is approximately. Option A is 0.1 electron volt, option B is 0.3 electron volt, option C is 0.7 electron volt, option D is 1.1 electron volt. So my dear students, I would like to give you that information here. So for the case of metal, just I'm giving that brief idea also about their surrounding concepts also. So for metal, their forbidden gap is approximately 0 electron volt. Then for insulator, it is very high. It is very high. It means I can say it here. This Eg is having that range as a 2.6 electron volt to 6 electron volt, or even higher than that, or even higher than this. Then apart from this, for the semiconductor, their order is nearly 1 electron volt. So order is 1 electron volt, means that for the semiconductor, this gap is somewhat moderate, which is lying between the gap of this metal and insulator. So due to that reason, it is called here as a semiconductor. And here their order is 1 electron volt. But exactly if we were to like talk about that germanium, silicon, and some other things. So here for germanium at room temperature, at room temperature means we can say it here as a 300 degree Kelvin. So for germanium it is 0.72 electron volt. For germanium it is 0.72 electron volt. For silicon at room temperature, it is 1.12 electron volt or simply 1.1 electron volt, and for compound semiconductor as a gallium arsenide, it is near about 1.42 or 1.48 electron volt. So these are the data you have to remember with respect to exam. So here it is not about that one question, here it is having that several data I have given to you, so that this will be very useful for your competitive exam. For all these, not only for this metal insulator semiconductor, this entire data will work out for answering many more questions. So this will be the way. So what you have to do, that you have to keep your notebook ready and then write down this question along with their answer, and just below of that under the discussion you can write this all the data, and you need to memorize, you need to mesmerize all those things. So that will be very much useful for your all the competitive exam, whatever it is. So these are the standard values at room temperature, whatever I have given. So this you must have to remember. So for this question, if you see it here, the energy gap for an intrinsic semiconductor at room temperature is nearly about 1 electron volt. So that is matching with option D. So option D is the right answer for this question. So now we'll move to the next question. So next question is, in an intrinsic semiconductor, the concentration of electron is option A greater than whole electron whole concentration, option B less than whole concentration, option C equal to whole concentration, option D 0. So whenever we are talking about that intrinsic semiconductor, then for the intrinsic semiconductor, the condition itself is concentration of electrons must be equal to concentration of holes, or ultimately we can say it here, that is N is equal to P is equal to Ni. So this condition you must have to remember for the intrinsic semiconductor, So based on this, the concentration of electron must be equal to whole concentration. So option C is the right answer. This option C is the right answer for this question. And by this way, you have to know this condition here. Now we'll go for the next. So next question is, the conductivity of a semiconductor is given by. This is very most important characteristic for the semiconductor, so that I can see it here as the electrical properties for the semiconductor. So conductivity is very important here. You must have to remember about this formula. You have to note down in your notebook. So conductivity of the semiconductor is given here as like, this is N into mu N plus P into mu P into Q, where N is the concentration of electron, P is the concentration of holes, mu N is the mobility of electron, mu P is the mobility of the holes, and Q is electronic charge. So here this is in general formula. For finding the conductivity of semiconductor. If we will talk about that conductivity of that N type of the semiconductor, then this will be sigma N is equal to what? This can be written N mu N into Q. So this is approximated formula, or this can be written here as a Nd into Q into mu N. So this is the conductivity of the electron. Similarly, this is the conductivity of the N type semiconductor. Similarly, for the P type of the semiconductor, you'll get it here. For this P type of the semiconductor, we can write sigma P is equal to P into Q into mu P. So here this is the conductivity of the P type of the semiconductor. And even for the case of metal, or in the case of metal, we have only the charge carrier as electron. So the conductivity of the metal will be called, or that can be written by this only. So here this can be for the metal also, we can say it here as a NQ mu N, where N is the concentration of the electron. Here this N is approximately to this ND, so it means what I am trying to say it here, that concentration of electron is similar to the concentration of the doping atom, so that due to that reason this can be approximated. So similarly here also this can be written as a Na into Q into mu N. So here this small p is approximately equal to Na. It means this conductivity will depends upon that doping, and this is depending upon the mobility of the charge carrier. So here this is for the N type, this is for P type. This is for P type. Whenever we will talk about that intrinsic semiconductor, so for intrinsic, what will be the change? For intrinsic, this N is equal to P is equal to Ni. So simply we will write it here as a sigma intrinsic is equal to N. If you substitute here, N is equal to Ni, P is equal to Ni, so Ni will be common. So we will write it here, Ni outside, and this is mu N plus mu P into Q. So my dear students, I am giving these all the formulas by discussing about the question itself. So you should not focus only to this question. You need to note down all these formulas also, so that not only this one, if they ask out of these questions also, you will be able to answer many more questions. So due to that reason, I am explaining all these things here. So now I hope you got that answer for this one. The conductivity of a semiconductor is given by option A is the right answer for this question. And if you know their conductivity, then we can easily find out resistivity of any of these. So that can be given. Rho is resistivity, that is reciprocal of this conductivity. And if their conductivity is known, we can easily find out the resistivity of the conductor. And if the resistivity is known, we can easily find out their resistance also. So this can be written in this form. So in this competitive exam, they'll ask the questions based on these formulas and based on these properties. So you have to note down this, or even you can take the screenshot. At the later stage, you can note down in your notebook. So by this way, the final answer for this question is option A. Now the next is, as temperature increases, the conductivity of an intrinsic semiconductor, option A decreases, option B increases, option C remains constant, option D first increases then decreases. So just now we had seen the formula for this intrinsic conductivity also. So here this is given, sigma intrinsic is equal to Ni into mu N plus mu P into Q. So here from this one, it is very obvious, as temperature increases, the conductivity of an intrinsic semiconductor, whether it will decrease, increase, remains constant, or first increase then decrease, like that. So here, as per this question, what you need to answer, this Ni is directly proportional to T raised to 3. So here what we can say that if temperature increases, then their Ni value is increasing because of thermal energy supplied more, covalent bond breaking will be more. So due to that reason, this Ni is increasing. So this sigma intrinsic is also increasing here, but this is having certain limitation also. The reason behind that, here this conductivity depends upon the mobility of this charge carrier also. So this is depending upon these two parameters. So for certain temperature limit, this Ni will be increasing as this temperature is increasing, and ultimately this sigma intrinsic will be also increasing. So this is limited to certain temperature range. So as per this question, their answer will be what? As temperature increases, the conductivity of an intrinsic semiconductor increases. So option B is the right answer for this question. Now we need to move next. So next is in an N-type semiconductor, the majority carriers are option A holes, option B electrons, option C ions, option D protons. So I hope you have studied about this semiconductor. So intrinsic semiconductor is having that concentration of holes is equal to concentration of electron. But whenever we are talking about an extrinsic semiconductor, so for N type of the semiconductor, that majority charge carrier is electrons and minority charge carriers are holes. Similarly, for P type of the semiconductor, majority charge carriers will be holes and minority charge carriers will be electron. So these points you must have to note down in your notebook. And here in this question, in an N-type semiconductor, the majority carriers are electrons. If they'll ask about that minority charge carrier, then the answer should be holes. So this will be very much useful. So those who are from the electronic background, they might be knowing about that all those things. But those who are from the other than electronic, so many of them may not be knowing about that. So for them it is new. You must have to note down all these points for your exam purpose as well as for your knowledge purpose also. So now we'll go to the next. So here in a P-type semiconductor, the impurity added is generally option A pentavalent, option B trivalent, option D divalent, option D monovalent. So here in P type of the semiconductor, the impurity added is trivalent. So that option B is the right answer for this question. But whenever we are talking about that N type of the semiconductor, so to transform intrinsic to N type of the semiconductor, the impurity added is pentavalent. It means in their valence orbit, their number of valence electron is 5. And here for this P type of the semiconductor, the element which is added here, their valence electron is 3. So due to that reason, it is called here trivalent impurity is added to the semiconductor, to the intrinsic semiconductor, so that it will transform to P-type semiconductor. I hope you understood this. Next is which impurity is suitable for producing an N-type semiconductor? Option A boron, option B aluminum, option C gallium, option D phosphorus. So whenever we need to transform or we need to produce N type of the semiconductor, then in intrinsic semiconductor, what the type of impurity added? So that is called pentavalent. And here as a pentavalent element, if you see it here, option D phosphorus is pentavalent element. So this phosphorus is added to the intrinsic semiconductor so that it will transform into N type of semiconductor. So option D is the right answer for this question. Now we'll see next. So next is the donor energy level in an N-type semiconductor lies. Option A close to valence band, close to conduction band. Option C at middle of band. Option D above conduction band. So here this is very important question with respect to exam point of view as well as for your knowledge also. So just we can put it here star mark. So here for the N type of the semiconductor, if you observe that their general energy band diagram. So this is their general energy band diagram. And here if you observe that this is valence band and the maximum energy level is shown as a EV. This is their conduction band. So this is shown here as a EC. And for N type of the semiconductor, their Fermi energy level is just near to this conduction band as well as their donor energy level is also nearer to this conduction band. So here this is called here their donor energy level. So this we can show it here as a EGD. So this is called here as a donor energy level. This is a donor energy level, and if we will talk about that Fermi energy level, so Fermi energy level will be also near about to this only, but this EF which is called Fermi energy level is not fixed at this point only. It can change as per the temperature changes, as per the doping concentration changes, but this donor energy level is having this just below of this conduction band. So here if you see that this difference between this EC and EGD is having as a 0.01 electron volt, 0.01 electron volt for germanium, and this is having 0.05 electron volt for silicon. So what I can say it here, this donor energy level is lying just below of this conduction band by the amount of 0.01 electron volt in the case of germanium as a host material, and 0.05 electron volt if silicon is used as a host material. So here what we can say, that it is very close to conduction band. So option B is the right answer for this question. If it is having P type of the semiconductor, so for P type of the semiconductor, their acceptor energy level is lying near to this valence band. That also you can make a note in your notebook. So here we learn about the two questions. One is for the N type, another one is for P type. If we are talking about that intrinsic, so for the intrinsic, we can say it here that their Fermi energy level is lying just at the center of this band gap, forbidden band gap. So here this is for the acceptor energy level, this is for the donor energy level, this is their Fermi energy level for the N type of the semiconductor. For the P type of the semiconductor, Fermi energy level will be near to this valence band, and that means it will be normally above of this EV, but that can be changed as per the doping changes. If we are talking only for the intrinsic semiconductor, then this is called their EFI, that is called Fermi energy level associated to intrinsic semiconductor. So that lies at the center of the band gap, approximately, not exactly. It is not exactly. So here by this way, this option B is the right answer for this question. Now we'll move to the next. So here the Fermi level of an intrinsic semiconductor lies approximately, just now I had given the answer. Option A at conduction band, option B at valence band, option C near the middle of the forbidden gap, option D outside the forbidden gap. So just now before of this question I discussed about that. So this is the energy band diagram for this intrinsic semiconductor. So here this is their valence band, this is their EV, this is their EC, and this is called their conduction band. So just add, this is our EG, this is our forbidden gap. So it is lying just where it is lying near to this middle of, this is called here EFI mid gap. So this is normally we can say it here as a EG by 2. Normally, approximately, it is not exactly that. Whenever I teach about that in detail, more precisely about this Fermi energy level for the intrinsic semiconductor, then you will find out where it will be. But normally, we can say that it will be near to this mid gap, near to this forbidden gap center point. So based on that, we can say it here that Fermi level of an intrinsic semiconductor lies approximately near this middle of for the forbidden gap. So option C is the right answer for this question. Now next is the drift current in a semiconductor is caused by option A concentration gradient, option B electric field, option C temperature gradient only, option D recombination. So here I should write about that the drift current in a semiconductor. So first of all I'll write the formula, then you can say their answer also. So what will be their answer? So here just I'm writing J in drift. J in drift. So this we can write it here as NQ mu n into E, or this can be written here NQ Vd also. Vd is called drift velocity. So here this is for the N type of the semiconductor. Similarly for the P type of the semiconductor, this can be written here as a Jp drift. So what will be changed? this n will change to p, q will be as it is, mu n will change to mu p, e will be common to both. So like that we can write it here, or simply we can write pq into vd also. So from this formula we can easily say about their dependency. So here if you see that this drift current density is depending upon the concentration of the charge carrier. If it is because of the electron, it means concentration of electron. If it is because of holes, it means concentration of holes. Q is the electronic charge which is constant. Mu n is the mobility of this charge carrier as the electron here. Mu p is the mobility of the holes. This E is electric field, here also E is electric field. If you will observe in this option, then what it is giving here, that is depending upon this electric field. As per the option, it is electric field. Concentration gradient is different. Here these are the concentration. So concentration and concentration gradient is different. This N is called here as a concentration. If we write here dN by dx, then this is called concentration gradient. So in our expression for this drift current density, nowhere it is dN by dx or dP by dx. So this is not the correct answer here. Temperature gradient only. So there is no dt like dt by dx or dt by a small dt. What I am trying to say that dt by dx or this temperature gradient with respect to time also, it is not there. So this is also not depending. This is also not depending. So this drift current density is depending upon that electric field. So that is mentioned here as electric field. Then apart from that, it is depending upon the concentration of the charge carrier. Then it is depending upon the mobility, or even here we can say that this J in drift can be written here as a sigma into E. So this sigma is called the conductivity of the charge carrier. So conductivity of the material. So here this sigma also, like this J in drift is depending upon their sigma also here. So now this sigma is the function of mobility as well as this concentration. So if the temperature will change, mobility will change. If the mobility will change, then this drift current density also will change. So temperature independent and temperature gradient both are different. So here nowhere temperature is mentioned in the option. It is mentioned temperature gradient. So that is not the correct here. If it is independently given as a temperature, then that should be also the answer here. So for this question, option B is the right answer, most appropriate right answer as per the question, whatever they had asked about that. So by this way, in one day, I'm covering about that 10 questions, and in this one, what you have to do, you have to make a proper notes over there and then write all those formula and listen to that concept whatever I'm discussing related to that questions very peacefully, and write those points also in your notebook and try to solve these questions also. So by that way, your exam preparation will be on the track, and I hope you can score very high. So now, whatever you got that score based on your self-evaluation, I'm going to release that their scorecard also. So here a scorecard is given. Whatever questions I had discussed, 10 questions. So out of those, if you got by yourself from 9 to 10 marks, then your response is called as the excellent response. So what you got, just to mention through that messaging, like through that comment at our channel. So here 7 to 8 marks, it means you got that very good marks. You need to improve more to come to the first category. Then we have that 5 to 6 marks. So 5 to 6 marks means simply good. And if you're below of this, then you have to learn more and more so that your preparation will be on the track. And here if you're scoring 3 to 4 marks, it means need high improvement. Then 0 to 2 marks, it is very poor. So you need to revise all your concept and try to maintain always in the first category, so that the chances of selection in any competitive exam will be very high. And my input, my effort will be always there to contribute for your betterment of your career. So how you feel about this video, these questions answer, and what the score you got it here, just to mention through that commenting at our channel, so that I am also getting your ideas, and give your feedback also. What the kind of improvement you're looking for, and what is your expectation for this series. I'll try to improve in the further videos also. So all the best, and thank you to all of you for watching this video. Then again we will meet in the next video with the next set of questions for the day 2. Thank you.